Good morning, children. In this module, we will learn the very first chapter of mathematics, that is, rational and irrational number. So, before we begin the chapter, we will go through some introduction of number system. So, number system is a system of representing the numbers. It is categorized into two parts. First is real number system, which is called real number system, and the second one is called imaginary. So let us understand what is the difference between real number system and imaginary number system. So in real number system, we learn about two types further. One is the rational number and the other is called irrational number. So your question is, what is imaginary number? So imaginary number is like, suppose I want to find the square root of 4. So obviously it results in 2. In case if I ask you what is the square root of 16, obviously the square root is 4. Why? Because 2 multiplied 2 gives the same quantity 4. Similarly, 4 multiplied by 4 gives the same quantity 16. So we have more examples like root 25. Talking about root 25, the square root is 5. Why? Because 5 multiplied 5 gives 25. But suppose if I ask you the square root of the square root of minus 25, then what will be your answer? Your answer cannot be plus 5. Why? Because plus 5 multiplied plus 5 gives 25. Now, your answer cannot be minus 5 also, because minus 5 multiplied minus 5 again gives the value 25, but under the root it is actually minus 25. So there is no possible value. By multiplying this with the same quantity, we will get minus 25. So we can say like root under minus 4, it's an imaginary number. Similarly, root under minus 25 is also an imaginary number because its square root is not possible. Not only the square root, we can say the cube root of the cube root of minus 4 cannot be determined. So such expressions are called imaginary number. Talking about real number system. So I hope the concept is clear what is imaginary and what is real number system. So here we cannot determine the value of root under minus 25. Similarly, we cannot determine the value of root under minus 16. Because we cannot say plus 4, because 4 4s are 16. Similarly, we cannot say minus 4 because minus 4 multiplied minus 4 gives 16. Again, it doesn't gives minus 16. So these are few examples of imaginary number. Let us understand what is rational number. So a rational number is further categorized into two parts. First one is the integers and the other is called fractions. Like integers, if we talk about integers, you know that integers is represented by capital Z. Similarly, rational number is represented by capital Q and irrational number is represented by q bar. Now let us understand what are integers. So you know better that integers can be -1, it can be -2, it can be 0, it can be 4, it can be 5 also. So the integers can be negative, it can be 0, or it can be positive. Talking about some examples, like if we talk about negative integers, we can say -3, -2, -1 and many more. The same way, talking about the examples of 0, there is a single unit, that is 0. Now positive, so positive can be 1, 2, 3, dot dot dot. So these are the positive integers. Now this 0, we all know that positive integers can also be categorized as, here I am writing, called the natural number. Why? Because you know that natural numbers begins from 1. So 1, 2, 3, 4, 5 and it continues and it is categorized as natural number. But when we include 0 to the natural number, we call it as whole number. So 0, when included to the positive integers, it is called whole numbers. For example, the list of numbers are 0, 1, 2, 3, dot dot dot. Okay. So now let us understand what is irrational number. So irrational numbers are numbers whose square roots or cube roots are not perfect. Like if we talk about root 81, we know the 81 is having a perfect square root, that is 9. 9 nines are 81. But if we talk about the square root of 2, there is not perfect root. Similarly, if we talk about square root of 5, it doesn't give a perfect value. Similarly, we can say of the cube root also, there is no proper cube root of 4. So we will write cube root 4 is an irrational number. We cannot say square root 4 is an irrational number. Why? Because square root 4 is having a perfect result, that is 2, and 2 comes under a positive integer. So we can say 2 is a rational number also. Now the concepts, I hope the concepts are clear, that square root 6 can be we can say that it's an irrational number because its perfect square root is not possible. Similarly, the square root of 9, no, it cannot be, but square root of 91 can be irrational number because its perfect square root is not possible. So what is the basic definition of rational number? So a rational number is a number which can be represented in the form of P upon Q, where P and Q belongs to integer and Q should not be equals to 0. That means we can go through the examples, like when we say of 2, so 2 can be written in the form of 2 upon 1. So here 2 is an integer and 1 is also an integer and it is expressed in the form of P upon Q. Here 2 is acting as P and 1 is acting as Q, and where this Q should not be equals to 0, and we can check that here 1 is not equals to 0. So these are the basic introduction of the number system. that a number system is categorized into two categories. Let us have revision. The first one, real number system. The second one, imaginary number. So, imaginary numbers are those numbers like under root minus 4, under root minus 25, under root minus 6, under root minus 8, under root minus 9, any value, but it should be negative. These are categorized as imaginary numbers because we cannot get its perfect result. Now, talking about real number system, real number systems is further categorized in two categories. One is rational number, the second is irrational number, which is the basic name of the chapter. Now, rational number are those numbers which can be expressed in the form of p upon q, where p and q belongs to integer and q should not be equals to 0. Now, this rational number is further categorized as integers, or it can be fractions like, for example, 2 upon 3, 4 upon 5. So these are the examples of fractions, or we call it as non-integral rationals. Now talking about integers, so this minus 3, the very first examples of a negative integer is here minus 3, which can be written as minus 3 upon 2. So here again the quantities are expressed in the form of p upon q. So we can categorize integers, whether it's negative, as rational number. Now there comes a question that is 0 a rational number? Yes, 0 is obviously a rational number because 0 can be written as 0 upon 1, which also gives 0. So that means since we are able to express 0 in the form of p upon q, so we can call it as a rational number. Now talking about positive integers, so here let us have an example of 3. So again the 3 can be written as 3 upon 1, which also gives 3. So the same way 3 is expressed in the form of p upon q, and we can check here the denominator 1 is not equals to 0. Now these positive integers are called natural numbers. Talking about whole numbers, as I said, when you include 0 to the natural number, we call it as whole number. So I hope you all have understood the questions, understood the concepts. Okay, so we will discuss some question. The question, I mean to say, there comes a question that is 0 a rational number? Yes, it's a rational number because it can be expressed in the form of p upon q, that is 0 upon 1. Okay, let us go through the example number 1 of the chapter first. So let us read the first example from your book. I expect each of you must be carrying a book while going through the lecture. Okay, so the first example is, which of the rational numbers 3 upon 5 and 5 upon 7 is greater? So in the example it's given 3 upon 5 and 5 upon 7, among these two fractions, which is greater? So to find the greatest fraction, we take the LCM of the denominators. Since the fractions are not like, it's unlike. So you know better, the LCM of 5 and 7 will obviously come out. 7 5s are 35. So we know the LCM is 35. So let us convert these unlike fractions into like fractions. So 3 upon 5. So this 5 can be multiplied with 7 to make the denominator 35. since we have multiplied the denominator with 7, so numerator should be multiplied with 7. It comes 21 upon 35. Now, this 5 upon 7, so this 5 upon 7 should be multiplied with, so 7 should be multiplied with 5. So the numerator should be multiplied with 5, which gives 25 upon 35. So we got the two like fractions, that is 21 by 35 and 25 upon 35. Now you can tell better which is greater. Obviously this 25 upon 35 is greater, which is having the more numerator since the denominators are same. So since this 25 upon 35 is the equivalent of 5 upon 7 and 21 upon 35 is the equivalent of 3 upon 5, so we can compare and say that 5 upon 7 is greater than 3 upon 5. Now the question adds, insert 3 rational numbers between 3 upon 5 and 5 upon 7 so that all the 5 numbers are in ascending orders of their values. So obviously, suppose when we have to insert a number between 3 and 5, what we basically do, we take the average, that is we add the two numbers and divide it by 2 and we get 8 upon 2, which comes to 4. The same way, for inserting 3 rational numbers between these two numbers, let us learn how to insert 1 integers first. So we will write 3 upon 5, which is obviously the smallest one. Then we will put the lesser than sign. Then we will take the average of these two numbers. So 3 upon 5 plus 5 upon 7 whole divided by 2, then less than 5 upon 7, which gives 3 upon 5 less than. Now we know the LCM of 7 and 5 is 35. So obviously let us solve in rough. So 3 upon 5 plus 5 upon 7, so it gives LCM 35. So 7 3s are 21 plus 7 5s are 35, 5 5s are 25, which gives 46 upon 35 and upon 2. So 46 upon 35 divided by 2 will obviously give you 23 upon 35 less than 5 upon 7. Now we have already inserted one rational number between 3 upon 5 and 5 upon 7. To insert the other two rational numbers, we will insert one integers between these two and the other integers between these two. So we will write 3 upon 5 less than 3 upon 5 plus 23 upon 35 upon 2 less than. Now we will copy this, the middle term 23 upon 35. Now we will insert one rational number, that is 23 upon 35 plus 5 upon 7 whole upon 2, then the last fraction, that is 5 upon 7. So when you solve this 3 upon 5 plus 23 upon 35, so it comes, this LCM will be 35. So 5 7s are 7 3s are 21 plus 23, which gives 44 upon 35 and whole divided by 2, so which obviously gives 22 upon 35. So the value becomes 22 upon 35 less than 23 upon 35 less than, now talking about this, so 23 upon 35 plus 5 upon 7 whole upon 2. So LCM obviously is again 35. So 23 plus 7 5s are, so 25. 48 upon 35 divided by 2, which gives 24 upon 35 less than 5 upon 7. So here finally we have inserted the three rational numbers. One is this, the second one is 23 upon 35, and the third is 24 upon 35, and what is the first? That is 22 upon 35. So if you have covered this lecture, you can complete the exercise 1A of question first and question 2. Thank you.